Now moving on to the spike protein pathologies. Here's just 5, and there are so many more. Number 1, blood vessels. Remember the ACE2 receptor. So the spike protein can get into the blood. It can bind to endothelial cells. It can downregulate critical endothelial junction proteins, and it can undermine the endothelial barrier, leading to thrombosis. What's that? Blood clots. Secondly, the blood itself. The spike protein can bind directly to ACE2 expressing platelet cells. That can enhance platelet aggregation, can contribute again to clotting events. Thirdly, the brain. It can degrade the spike protein, the blood-brain barrier integrity, which is what helps to modulate and protect the passing of material between the blood and the brain. And that can risk the delicate neural networks the other side. That could cause neurological problems and affect the brain. Fourthly, the toxicity. This is slightly more complicated. Because the spike protein can attach to ACE2, it can cause downregulation and a decrease in ACE2 expression. But why do we need ACE2? Well, ACE2 prevents a toxic overabundance of a peptide hormone called ANG2. It helps it to convert from ANG2 to ANG1 to 7. If you have too much ANG2, because you don't have enough ACE2, you can have an increase in blood pressure, and it can cause hypertension and severe pulmonary and cardiovascular disease. Fifthly, and this is very worrying, recent computational evidence and evidence from in vitro laboratory experimentation shows us that the spike protein strongly interacts and impedes with key tumor suppressor proteins that repair DNA damage. And as I put there's no evidence that that 2P mutation, which was known from MERS, that Pfizer and Moderna applied and AstraZeneca doesn't have it, that makes spike any safer. And if it really did, well, how can we use AstraZeneca then?